Hello everyone, let's now solve some two-variable systems, but we'll do it algebraically instead of just graphing it. So first, as a reminder, when it says when we solve a system, what are we finding? We're finding the point of intersection. Okay, so we're finding the point of intersection, where the two lines run into each other, the point of intersection. And I want an ordered pair. So an x comma y is my answer. Now this says, consider the system, x equals 2, that's a vertical line, and then 2x plus 8y equals negative 12. If you know x is 2, how would you use substitution? Well, what you're going to do is take that x and you're going to plug it in the other equation everywhere you see an x. So instead of 2 times x plus 8y equals negative 12, now that I know x is 2, I'll plug in a 2. And then I just solve. 2 times 2 is 4. To get 8y by itself, you subtract 4. 8y equals negative 12 minus 4 is negative 16. And then when you divide by 8, negative 16 divided by positive 8 is negative 2. So the x coordinate, we already knew x was 2. Now we know that y is negative 2. So the solution to the system is 2, negative 2. In that one, so it's pretty easy. The next ones we'll have to solve x and then get y. So here it says, we know what y equals. Now, if you know what y equals, you have a really nice, easy substitution to do, because in the other equation, instead of writing y, I'm not going to write y anymore. I'm going to say 6x plus, I'm not going to write y, equals 3. Not negative 3, 3. Instead of writing y, I'm going to write what y equals, which is negative x minus 2. And the reason that you do this, what this accomplishes for us, is now we have one equation with one variable. You can solve it if it's got one variable. If it's got two variables, you need to combine them. That's what we're doing here. We're combining them into one equation with one variable. If you do a substitution and you still see x's and y's, you did it wrong. Okay, you should only see one variable. That's the whole point of the substitution. Now we just combine like terms. 6x and negative 1x make 5x. 6 minus 1 is 5. Negative 2 doesn't have any like terms on that side. Now I will get x by itself. The opposite of subtracting 2 is adding 2. 3 plus 2 is 5. And then when you divide both sides by 5, x equals 1. Great. We have x equals 1. Now, a solution has to have the y coordinate. Well, I don't know the y coordinate. How are you going to get it? You got to plug it back in. It doesn't matter which one you plug it into. I'll plug it into both this time just to show you. Y equals the opposite of x. Well, the opposite of 1 is negative 1 minus 2. Well, that's negative 1 minus 2 more is negative 3. So this must be negative 3. Now I picked the top equation, but you could have picked the bottom equation. 6 times 1 plus y equals 3. The 1, again, I'm plugging in this right there. So instead of 6x, I know what x is now. 6 times 1. 6 times 1 is 6. To get y by itself, you subtract 6. 3 minus 6 is negative 3. Oh yeah, of course, it's the same in both. It's a good way to check by plugging it into both, because if it's not the same in both, you did it wrong. Okay, it has to be the same in both, because this is the only point in which two lines can only intersect in one point, and that's it. Okay, so that's a little fancier. Let's try another one. Wait a minute. I think I know what's going to happen here. If this is what y equals, then I'll come in the other equation and I'll write what y equals. Instead of writing y, instead of y equals, I'm going to put 3x plus 6 equals 3x minus 30. So if they both equal y, I'm basically just setting them equal to each other. But you are still doing a substitution. Okay, everywhere you see a y, you're going to write what y equals. So you're just plugging it in. It just looks weird. Now this is going to get real weird when I collect my like terms. I'm going to subtract 3x on both sides. 6 equals negative. 6 does not equal negative 30. And no matter how hard 6 tries, it will never equal negative 30. So what's going on here? This must be one of those weird ones. Let's see. Wait, what happened? Okay, so why is this happening? Well, they have the same slope, and they have different y-intercepts. They're parallel. These are parallel lines. They have the same slope and different y-intercepts, so there is no solution. And when you do these problems algebraically, when you get a statement that is not a true statement, 6 does not equal -3. There's no variables there. That's just a false statement. We broke the equation. We're like, something's wrong. I can't solve this. You can't solve it because they don't ever intersect. Okay, so there is no solution. And if you want to kind of verify that, I mean, you should know they have the same slope, so they're parallel. But if you want to graph it, you can graph it. Here's 3x plus 6. Here's 3x minus 30. You can see one has the y-intercept at 6, one has it -30, and they just don't intersect. Okay. And then, well, if you zoom out enough, it looks like they're the same line, but they never intersect. Okay. So because they're parallel, they do not intersect. And the way that shows up in the algebra is that you get a false statement. You get something that doesn't equal itself. You get something weird. Okay, so that's one of the weird cases. And what I'm going to do is now pick some of your example problems. I'm going to do just some of them. I'm not going to do all of them. I'll do the first two and the last two, maybe the easier ones and the harder ones. Okay, so let's do a couple. First, I have a variable isolated. That's a good sign. I'm going to do a substitution. In the other equation, I'm not going to write y. I'm going to write what y equals. So let's say -x minus 3. Don't write y. Instead of y, you're going to put what y equals, -2x plus 6. Now notice, I only have x's. That's good. That's good. So we're going to have to distribute -x. -3 times -2 is +6, and -3 times 6 is -18. X, -1 and +6 make 5x. And now I'm going to add 18. 18 plus 7 is 25. Last step, to get x by itself, divide by 5. X must be 5. Okay, so I have the x coordinate. Now I need to get the y coordinate. It doesn't matter which one you use, but it looks like the second one is going to be easier, so I'm going to pick the second one because I can just straight plug it in. Y equals -2 times x is 5 plus 6. So I'm taking this and I'm plugging it in right there. -2x plus 6, -2x plus 6. Now I just need to solve. -2 times 5 is -10, and -10 plus 4 is -6. So the solution is 5, -6. Sweet. One down. Let's do another one just like that. I'm going to do a substitution. Instead of y, I'm not going to write y. So I'm going to say -5x plus 6. Don't write y. You're only allowed to write x's now. Instead of y, I'm putting what y equals. That is x minus 5. Now I have to distribute in this one as well. So let's go. -5x doesn't change. 6 times x is 6x. 6 times -5 is -30. Combine like terms. 6 minus 5 is 1x. To get x by itself, I'm going to add 30. 30 and -23 make +7. So x is 7. And now again, I'll plug x right in. Y equals, instead of x minus 5, I know x is 7. 7 minus 5 is 2. So the solution to this one is 7, 2, because 7 minus 5 is 2. Okay? So there's the first two. Now I'm going to skip the middle, and I'll do the last two for you, because I know the last one's weird. Number 7, let's see. I want to do a substitution, but I don't have x equals. I need x equals or I need y equals for this one, and I don't have that yet, but that would be easy to get. So what I'm going to do is add x to both sides. Y equals x plus 3. Now I have a substitution, so I'm going to use those two equations. Instead of y, I'm not going to write y, I'm going to write x plus 3 instead. So my substitution is -3x plus 3, don't write y. Instead of writing y, you're writing what y equals, x plus 3. Distribute, -3x plus 3 times x is 3x, 3 times 3 is 9. Uh-oh. 9 equals 4? No, it doesn't. This must be no solution. These must be parallel. But if they're parallel, then I should be able to see it. But actually what I'm going to do is I'm going to, just to kind of help you see it, if you triple this, see how it's -3x and +3y? It equals two different numbers. -3x plus 3y can't equal 4, and -3x plus 3y can't equal 9. It's got to equal one or the other. Okay, you can't have it equaling two different things. So if you solve both of them for the slope, you can say they're parallel, but I can also see it this way. I can just say, look, these are the same line, but they have a different y-intercept. The same slope, different y-intercept, okay? Let's do one more, and this one's got some fractions in it, so I'm going to give you a couple tips here to make this easier. If I see 1/8 of a y, I'm going to multiply everything in this problem by 8. It's going to make it a lot easier. 8 times 1/8 is 1. Those just cancel out, so that's 1y. And 8 times 4 is 32. And 8 times 1/2 is 4. I'm going to use that line, okay? And I'm going to do the same thing in this equation. I'm going to multiply by the least common multiple between 3 and 2, which is 6. And this is a fancy one, okay? 6 times 1/3 is 2x. And 6 times 1/2 is 3y, and 6 times -2 is -12. So by scaling these lines up, they're going to be easier to work with instead of having to deal with fractions. You just have to think what's the common multiple to clear that fraction. Now I have a substitution. Instead of y, I'm going to put what y equals. So I'm going to say 2x minus 3y, but I'm not going to write y. I'm going to write what y equals, 32 minus 4x. Now I will distribute. 3 times 32 is 96, and then it's plus -3 times -4 is positive 12x. 2 plus 12, those are like terms. 14x minus 96 equals -12. Go ahead and add 96 to both sides. 14x equals 84. And now I need to divide both sides by 14, which 60 and 24 is 6. X equals 6. X equals 6. So 84 divided by 14 is x equals 6. You can use a calculator if you can't do that in your head. Okay, x equals 6. Now I got to go back up top and find y. So I'll say y equals 32 minus 4x. Well, I know x is 6. 32 minus 24 is 8. So 6, 8 is my solution for this one. You can't really see that right there. There you go. Okay. So 6, 8 is my solution for this one. Now, that one was the trickiest because, again, you had those fractions and you had to get rid of those fractions. So what I did was I thought of a common multiple between 2 and 8, which is 8, and a common multiple between 3 and 2, which is 6. And I cleared the fraction and I created two equal equations, but just much easier to work with. So good luck on your problems, and make sure you smash that like and subscribe button.